I told you you're going to continue to learn more and more rules. So today, and the rest of the week, we're going to be adding negative exponents to our rules. Negative exponents. We've learned negative exponents before. Who remembers what a negative exponent actually does? Mackenzie? It flips it. So a negative exponent is actually a reciprocal. It is not a negative number. Coefficients are negative, right? A negative times negative is a positive, whatever that is with a coefficient. We're talking about exponents. Remember, we've been saying this for the past week now. We need to separate coefficients, the numbers out front, those integers, from the exponents. Those are two different sets of rules. And that's what gets really confusing. So, a negative exponent, like x to the negative n, means a reciprocal. So what this is doing here is it's giving the n to both pieces here, and that's why it's 1 over x to the n, because if you multiply 1 1,000 times, it'll still be 1. So a number to a negative exponent becomes a reciprocal of the number to the positive exponent. Reciprocal is another way of saying flip. A negative exponent does not equal negative number. So make sure you are not changing your numbers negative or positive because of a negative exponents. They don't change the sign. Negative exponents do not change the sign of the numbers. It just flips it. It changes the sign of the exponent. Go ahead and flip to the next slide when you are ready. So here are some examples here. So if we do 2 to the negative first, notice that does not mean it's negative 2. That's not 2 times negative 1. That's 2 to the negative 1. It's an exponent. So to get this to change to a positive, so to change to a positive exponent, flip it. Flip the base. So like this is 2 over 1 because it doesn't have a denominator. So I give the 1 to both the top and the bottom. 1 to the first is 1, 2 to the first is 2. Notice a negative exponent does not mean a negative number. It's not saying 2 times negative 1. That's a very different thing. Okay, so Avery, what would my answer be for 3 to the negative 1 then? Yeah, because you have 1/3 to the first power when you flip it, which is just 1/3. When you flip it, it changes the exponent from positive, or from negative to positive. You're not allowed to have negative exponents in your answer. Vivian, how would I do 7 to the negative second? What does the negative mean? So flip 7. How would I flip 7?
Make it 1/7.
So we have 1 over 7 raised to the second power. So what do I do with that once I have it to the second power?
Multiply 1/7 by 1/7.
Yeah, we do 1 times 1 and 7 times 7. So that's 1 over 49. Okay, Jacob, how would I do the last one there? 5 to the negative third. How many times do you have to multiply it?
3.
Yeah. And then you multiply it that many times. So look at those and see if you have any questions. Those are pretty simple. Today's is not going to be the harder stuff, like the first day we did, but we'll get harder over the next couple days still. But it's just challenging because you guys have to remember negative exponents do not mean negative numbers, like the negative coefficients. They mean a reciprocal. So what questions do you guys have for me so far? All right, so what if it's a fraction to start? If it's a fraction to start, again, to change a negative exponent to a positive exponent, flip the base, which is a reciprocal. That makes it positive. So we then do 2 to the first and 1 to the first, which is just 2. So Morel, how would I do the first one?
You have to flip it
To become what?
4 over 1
To the what power?
to the first power.
So that just means we do 4 times itself, or 4 times 1, or well, it's just 4. And then over 1, which is just 4. What I meant to say there is, you just list out 4 once. Okay, Jacqueline, how do I do 1/5 to the negative second?
5 over 1.
So what does 5 over 1 to the second power mean? You got to give the 2 to both of them. What does that mean? We've been doing this. This isn't new.
5 times 5.
Yeah, so your goal is to get it to look like the problems we've already been doing. Once you make it so there's no negative exponents, it should look like the last couple days. All right, questions there? Any questions so far? Okay, so the product property says when you multiply, you add the exponents, right? So what I'm going to do differently than what these are doing here is I'm actually going to get rid of negative exponents first, no matter what. We're going to get rid of negative exponents first so it makes it look like the problems we've been doing the last couple days. So instead of doing it this way, you could make this 1 over x squared times x to the 5th, which then becomes the quotient rule, right? Because you have a numerator and denominator. So with the quotient rule, we subtract our exponents, which gives us x to the 3rd. It doesn't matter which way you do it. I just think that it might be better for you guys to get rid of negative exponents because negative exponents can get confusing and sometimes you want to change things to negative numbers then. So for this one, you would do x squared over 1 times 1 over x to the 5th. So if I subtract that, that's 2 minus 5, which is x to the negative 3rd. Can you keep negative exponents in your answer? No, so that's 1 over x to the 3rd. So that's another way of going about it. Not the only way to do it. I don't care which way you do it. I'm just giving you another option. Okay? So again, if you do it a different way and still get the same answer, I don't care. But if you do it this way, all you did here was just add the exponents. So they just did negative 2 plus 5, which gave them this. And this one they did 2 plus negative 5. Okay? So either way is fine. So Hannah, help me out with number 1. Oh, it's not really number 1. X to the negative 2nd times x to the 1st. What would you do? I don't care which way you want to do it.
That would be x to the negative 1.
So you're adding the exponents, I'm assuming?
Yeah.
And can we keep negative exponents in our answer? No, so what does that become?
1 over 1 to the 1st.
1 over 1? What's your base?
Okay.
So it should be 1 over x to the first power, right? Which is just 1 over x. Okay, Avery, help me with the next one there. X to the negative 11th times x to the negative 4th. So you're adding them, right? And we can't simplify x's. If that was a number, you would have to list that out 15 times, but we're not doing numbers there. Okay, Kelly Etheridge, you're going to do the next one. 2 to the negative 3rd times 2 to the negative 5th. So remember, do they have the same base?
Yeah.
Do we ever change the base? No, that does not become 4. Do not change it to 4. So our base stays 2. So what are you going to do with the negative 3 and the negative 5, Kelly? So what's 2 to the negative 3 plus negative 5? Okay, so then we have to do what with the negative exponent? What does a negative exponent mean? What do we keep saying negative exponents mean? What?
Make it positive.
We need to make the exponent positive. How do we make the exponent positive? So how did they make the exponents positive here? What did they do in these two problems to make the exponent positive? They flipped it, right? So yeah, you can put it over 1. So 1 over 2 to the 8th, which is 1 over 2 times 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 2. So what's 2 to the 8th power? Can somebody tell me? 256. You bring this to your mom. Your brother left it in here now that he's in. Plus, he would never give it to your mom, probably in the first place. All right. Sarah R., help me out with the last one there.
You add the exponents of the 5 to the negative 4.
And then what do you do?
You flip it, so the 1, 5 to 45.
Which means?
1 times 1, 4 times, and 5.
Yeah. And if we do 1 4 times, I'm just not going to write it because it's just going to be 1. So what's 5 times 5 times 5 times 5? 625?
Yeah.
So we get 1 over 625. All right, questions on that slide? All right, then let's talk about the quotient rule. The quotient rule tells you that if you divide, you subtract the exponents. So you're going to subtract the exponents. Again, I find it easier to get rid of negative exponents first. So I'll probably do the second one with you, but let's start with x to the 4th over x to the 10th, Alex. So how would I do x to the 4th over x to the 10th?
Divide.
What do you do when you divide? If you have 4 x's on top and 10 x's on bottom, let me count 1 second. You don't add them. What are you going to do here? They simplify, so what are you actually doing? And where, so you would do technically x to the 4th minus 10, which is x to the negative 6th, right?
Yeah.
Which becomes what?
1 over.
Good. Now, you could always just subtract. You can always look at this and just say, well, there's 10 is a bigger number than 4, so the number has to be in the denominator, right? So that's another way of looking at this. The problem is when you talk about negative exponents, that doesn't always work that way.
You can just do like 4 minus 10 instead of having like, so you can like skip those steps.
This step here?
Yeah.
Oh, definitely. I was just trying to get Alex to figure out the rule because he told me to add them. So that's why I did that. But remember, if you forget rules, that's the best thing to do is to list things out. So there's 2 ways to go about this. One way, you could instantly change this so that you don't have negative exponents. Notice, did I move the x to the 4th? Is there a negative exponent in the x to the 4th? So should you move it? No, you only move things with negative exponents. So since this is in the numerator, it goes to the denominator. If it was in the denominator, it would go to the numerator. So then that just becomes 1 over x to the 4th plus 7, which is 1 over x to the, thank you, I almost put 13 there. I appreciate it. Or you could do the subtraction, and you would get 1 over x to the 11th. So again, does it really matter which way you do it? Sometimes I like getting rid of the negative exponents first because in a problem like the bottom one here, which I will do with you guys too, you guys forget that you're subtracting a negative, which doesn't change to a positive. And that's why I try to get rid of those negatives first, so you guys don't make those little mistakes. Yeah? Are you looking at the top one or the bottom one? What are we looking at here?
It's not negative,
You're subtracting. Negative, this isn't negative itself. You're subtracting a positive 4. That's why I'm saying I like to get rid of those negative exponents sometimes. So how would you, Madison, do the 2 to the negative 2nd over 2 to the 8th? I don't care which way you do it. Do you have to move the 2 to the 8th? No, because it has a positive exponent. Do not move it. Okay? Then what do you do from there? Which means 1 over 2 times 2 times 2 times 2 times 2. That's 5, right? 6, 7, 8, 9, 10. So what's 2 to the 10th power? What is it, Katie? All right, and then this one I'm going to show you 2 different ways of doing it. You could get rid of the negative exponents first. So 6 to the 8th would go to the top to make it positive, and 6 to the 3rd would also move because they both have negative exponents on them. Do you see that? So then you can do your subtraction, which is 6 to the 5th power. What's 6 to the 5th power? What's 6 times 6 times 6 times 6 times 6 times 6? 7,736?
76, yeah.
So 776?
Yeah.
Okay. Or you could, from the beginning, subtract. This is why I don't like you guys to do it. Because this is what I often see. You have to do negative 3 minus a negative 8. But what I'll often see is negative 3 minus 8. That's a negative 8 there, right? You're subtracting it. So you have to be very careful if you're going to do it this way. I really do not prefer for you to do it this way, but I'm not going to say you can't do it this way. So you see how you have minus a negative 8, which kind of goes off your question last time, Hannah. You know, why is it negative? Well, it wasn't a negative. I was subtracting a positive. Now I'm subtracting a negative. Do you see that? So 2 negatives become a positive. So I get 6 to the 5th power, which we already learned was 7,776. All right? So I don't prefer you guys do that because a lot of you guys will not do minus negative. You'll just do minus 8 because you think you're subtracting, and then that gives you the wrong answer. Okay, 2 more slides, and then you get your homework. All right. So a power to a power is you multiply the two. What I would like to do is get rid of negative exponents first. So if there's a negative exponent on the inside of the parentheses, get rid of that first, but there isn't in this one. So then I would actually do this, is flip it to make it positive. And then that would be 1 times 1 times 1 on the top over x squared times 3, right? 2 times 3 is 6, which is 1 over x to the 6th. So instead of just multiplying right away, getting rid of the negative exponents sometimes prevents you guys from doing things wrong with the numbers. So when you guys will have coefficients in front tomorrow. So that's why I'm kind of showing you this way now, even though it's easier now, but you guys are going to have a lot of coefficients tomorrow, and I kind of want to prevent some of those things from happening tomorrow. So you can still do it this way. 2 times negative 3 is negative 6, which means you reciprocate it. Do you get the same answer either way? Remember, your base never changed the same. You multiply 2 or more exponents on a single base. So for this one, I would do 1 over x to the 5th squared, because that makes it positive, which is 1 over, so that's 1 times 1, over x to the 5th times 2, because you have 5 x's listed out twice, which is 1 over x to the 10th. So for this one, I would start on the inside. So this becomes 1 over x squared to the negative 1. That makes that one positive. But then we have the negative exponent on the outside, so that becomes x squared to the positive 1. You can do that over 1 if you want to, which is x squared times 1, and then 1 times 1, which is just x squared. Again, that seems tedious to do today because if you would have multiplied those, you would have gotten there right away, right? But my problem is that they're going to get more complex, so I kind of want to see those steps. I'm doing those steps now so that when we get more complex, you'll see where we're going. So I would do 1 over 4 to the 5th, which is 1 over 4 times 4 times 4 times 4 times 4. What is that? 1024. So I have 1 over 1024 to the 3rd power, which is 1 over, so it's 1 times 1 times 1, over 1024 times 1024 times 1024, which is, okay, 1 second. A very big number. 1 over, I don't even know, that's 3, I think it's 1 billion. 73,741,824. Thank you for letting me steal your calculator. All right, questions there?
Wait, so can we not?
You can. Remember what I said. There's multiple ways to do it, and I don't care. This is just what I would prefer for you to do. That doesn't mean it's right. Okay? So what I would like you guys to do now